So artificial intelligence is really an ill-defined term because it's not really clear what, in general, what we mean by intelligence. So what I focus on here is machine learning because learning really is a well-defined term, but actually most of the things that you think of as artificial intelligence, voice recognition, picture classification, things like that, are actually machine learning. And so what machine learning is basically algorithms that learn how an output, which we're going to refer to as y, depends on the input, which we're going to refer to as x. And so the whole thing can really be summarized in this equation here, right? So we need to find this function f that gives us an output given an input. And so the simplest function that you can think of, the simplest form of f, is this equation here, where y just depends on x multiplied by a constant, and then you have an intercept here, b. So that is known as linear regression. So like every other field, machine learning has its own set of terms. So what you normally think of here is linear regression with m as a slope and b as an intercept. In machine learning lingo, here you usually write the equation a little bit backwards so that the intercept, which we call the bias, comes first, and then the slope, which we call the weight, comes second. Also, we use the term y here for the actual data points, and then the y values we get from this equation is then y predicted. Okay, let's actually stop talking about the theory and actually do some coding. So I'm going to go over here. I'm in my Google Drive. I've made a blank folder. And I now want to code up linear regression using Python and Google Colaboratory, which you can find here. If you don't see this option in your Google Drive, you need to add it here by searching for Colab and then installing it. Now, I already installed it, so you see I get a green check mark. Otherwise, you have to click this button here to install it. So let's fire it up. Okay, and so here we are. The first thing I want to do is rename the file so I know what's in the file. And I'm going to call it linear regression. Okay, then we're going to start with some data. Now, that's going to take a little bit of typing in this case, so I just going to copy it and paste it in here. So here are my x and y values, right? So here's my first set of x and y values. Here's the second set, and so forth. So I have x here and y here. Okay, so the first thing we're going to do is we're going to try to plot it. And so in order to plot it, I need separate lists of x and y, as you'll see. So to plot it, I'm going to use a library called MatPlotLib, and I'm going to use a sub-library here called pyplot, and I'm going to rename that as PLT because I don't want to type it all the time. So I'm going to put that in a cell by itself. Here's my other cell, and the point I eventually want to get to is that I want to type plot. I want to scatter plot, and I want to plot my x and my y. That's how MatPlotLib wants it. So the next thing then is how do I separate my x values and my y values from this data set. And so anytime we have to do with data in Python, usually the best thing is to use another library called Pandas. So I'm going to import Pandas and I'm going to abbreviate it as PD. Okay, so let me run this cell. So far I've just typed things. Now in order for this to take effect, I need to run it. You can do that either by clicking this button here, and it's starting up. And I didn't get any error messages, so that's good. Another way to run it again is to hit Command Enter, which I'm going to use from now on. Okay, so let me get this x and y into a Pandas data frame, which is the way Pandas thinks about data. So I'm going to call my data frame Pandas. I'm going to use the Pandas library, which I abbreviated as PD, and I want to make a data frame. And I want to make it from my x and y list here, and I want to separate it into columns. The first column is going to be called x, and the second column is going to be called y. Okay, so oops, I want that here and go out here and hit return. Okay, so in Google Colab, if you want to, you can either print something out, as I'll show you later, or you can just type it as the last line in a cell. So if I just type data here, I should be able to see what this data frame looks like. Okay, and so here you can see I now have a table. The leftmost thing here, that's just an index, and Python and Pandas and everything in Python usually count from 0. So this is my 0th entry, and I have 10, so this is my 9th entry. And I have the x coordinate here in this column and the y coordinate here in this column. Okay, so that looks pretty good. Okay, so now all I need to do now here to get my x and y from my data frame is to type, to tell it I want to use my column labeled x here for x and my column labeled y here for y. Okay, let's see how that works. Okay, I got an error. And, oh, yes, so I can, it has no attribute scatter plot. So if you look that up, that's, if you looked at the MatPlotLib library, that's exactly true. It's actually called scatter. Okay, and so here are the points. So here are my y values. Okay, so the next thing I want to do is I want to try to make a model that predicts this. I want to make a machine learning, a linear regression model. So I want some y predicted. Right, and I'm going to write this in terms of a bias and a weight times x. Now, so I actually have to define what that is, and I don't really know, but I'm going to start with just, let's try to set it to both of them to 1. Okay, so this is a guess at my parameters in my machine learning model. Okay, so let's try to plot this line also. Right, so I want to plot my y predicted against my x values. And now I want to plot it as a line, so I use plot here instead of scatter. Okay, well, it doesn't look too bad, but I probably could do a little bit better. Maybe my slope needs to be a little higher. Okay, that seems a little bit better. Maybe my intercept should be a little smaller. Whoops, I probably should give that a value. Oops, sorry. I was messing that up. So I want my slope a little larger and maybe my intercept a little smaller. Okay. So, okay, that looks a little bit better. Now, it would be nice to have some kind of measure of whether I'm doing better or worse, right? Because right now I'm just sort of eyeballing it. So it would be good to sort of calculate an error. So what should that be? Well, the error really should be the difference between the actual points, my data points, and the ones I predicted. Like this. So let me try to print that and see how I'm doing here. Okay, so that gives me an error for each point. That's better, but that's not really what I want. I probably want the average of this instead. Okay, so to compute an average, I need another library called NumPy. So I'm going to go up here and import NumPy as NP. I'm going to abbreviate it as NP, and I'm going to run it so that it's loaded. And now I want to use the mean function. In NumPy. And now I should just get an average of all these values. Yeah, okay, good. So that looks pretty small. Let's try to see what happens if I change the intercept. Does it get better or worse? Okay, that got worse. Right? You can kind of see it here too, but you can definitely see it on the value. So let's try. Okay, so that's good. Let me try. Maybe I should make it even bigger here. No, that got worse. So the error actually got smaller, right? But it's a smaller negative value. What I actually want is an error that's close to 0. And so actually what a lot of people do to avoid confusion, right? Because this is smaller than this, but it's actually worse. So it's better to talk about either the absolute error, or what a lot of people do is talk about the error squared. So let's square this. So in Python, you do that with 2 stars. And okay, so now I have a value here. Of course, it's larger because I square it. Notice that it's the average of the error squared, right? So it's not the 0.25 squared, it's the average. So it's not the it's not the average error squared, it's the average of the error squared. But either way, it's just a number, and the question is whether it now gets bigger or larger, bigger or smaller when I go to 2, for example. Okay, it got a lot bigger. Okay, so bigger mean squared error, worse plot, right? Mean squared error is kind of That's kind of a mouthful. So in general, in machine learning, the thing we're trying to make as small as possible, we usually call the loss function or the cost function. Now, there are many kinds of loss or cost functions. If you go with the average of the error squared, then that's usually referred to as L2, right? So L for loss and 2 for squared. So actually, let's define that. Let's move that up here. So that I know what it is. And actually, what people do in many cases is multiply this by a half. Now, I'll show you later why that is. It doesn't really matter with the constant, right? So let's print my L2. Excellent. Okay, now before we go on, why don't we stop here and why don't you code this up and try to play around with these two parameters and see how low you can get the error.